Let's talk about how to make code that'll calibrate itself. So the whole point of this thing is you got some device and it requires a certain range of values, and those values might change depending on where you're using it. So in this case, we got a light theremin, and it wants to map light levels that the photoresistor can put out to a reasonable range of frequencies in normal human hearing. Now that could depend greatly on the lighting of your room. If you're going to make this code for multiple devices, it might depend on how you've got the circuit wired. But if you've got this calibration code in, it'll just figure it out every time you turn it on. It'll find the best values. So what this one here does is it takes the first 5 seconds and it looks for the lowest light value it sees, and it looks for the highest light value it sees. And by knowing the minimum and the maximum, it can map the minimum value it actually saw in the first 5 seconds to like the low end of human hearing, and it can map the highest light value it saw in the first 5 seconds to the high range of human hearing, and then you're not always going ultrasonic or whatever, or missing some of your range. It's just perfectly set up. I used to use code like this quite a bit for line following robots. You go build your robot on your dirty mat at the school, and it would have much different reflectivity than the more recently made competition mats. And so if you hard coded it, you'd get the values all wrong, because the blacks would be less black and the whites would be more white when you went to competition. The lighting would be different. But with some calibration code like this, perfect every time, no matter where you're using, no matter how light it is or not. Anyway, so that's what we're doing. Let's talk about how it works. So to start off with, we initialize 3 variables. One to hold what we get out of analog reads, so we don't have to initialize it every time, every pass through the loop. And one to hold the lowest value we see in the first 5 seconds, and one to hold the highest value we see in the first 5 seconds. And those will be constantly updating. The reason sensor low starts up at such a ridiculously high value is we want that value to change later on the code. We have to get, there is no way we will not end up in the first 5 seconds with a value less than or equal to this number, and that's good. That way we won't screw up our calibration. So it is a very good idea to set your minimum value initially to the maximum possible, and your maximum value to start off with to the minimum value, because that way later on in your code they will update to the correct values. Whereas if you set the low value too low to start and you ended up in a really brightly lit place, it might throw off your range. Let's say you're like, I don't think it'll ever be, my minimum will always be less than 300, so I'll just start it at 300, and then you end up in this super brightly lit competition or something, and the minimum's 400 in that circumstance. Then you'd get your range wrong, because it would think the minimum value you hit is 300 instead of 400. Yeah. So a good idea to start low values at max possible and high values at minimum possible, just so it updates here. And so for this code, we've got a nice little indicator to tell us that we're doing calibration code. So we've set the built-in LED on the Arduino to an output, and then turn it on, and then start doing something over and over for the first 5 seconds. So our calibration is just constantly running in a big loop. So the loop is whatever's inside the while loops brackets for the first 5 seconds, 5,000 milliseconds in 5 seconds. So every pass through the loop, we check out what the heck we're reading off our photoresistor and save it in sensor value. And then if that value we just got off that photoresistor is bigger than any we've seen before, let's say our previous max was 750, and now we just got off our analog read off our photoresistor, we just got 800. It was 750, now it's 800. We want to update our high score. We want to update our max value. So now we set our high score equal to the value we just saw because it was bigger. So now our max value is 800. It's updating. It's doing what it should. And then here we got the same thing for if we see a lower value than we've ever seen before. So let's say the previous lowest we'd ever seen was 300. Now we just saw 250. And we're like, oh man, that's a lower value. Time to save it as my minimum value that I saw. And so we set our minimum value equal to the thing we just saw, the 250 instead of the 300. And that's it. It just keeps doing that again and again. It's a good idea to wave your hand in front of it, just so you get a full range of values you're likely to hit. But really, that's it. So quick recap. Make 3 variables, one to hold the thing we keep getting off analog read, one to hold our minimum value. We initialize it high, just so we can be sure it'll update later on in our code. And then we get our max value and we initialize it low, just so we can be sure it updates in our code and actually ends up being the max value we saw in the first 5 seconds. Then we got our handy dandy LED pin that turns on just for fun. And then in the first 5 seconds, we just keep reading off that photoresistor, and if it's bigger than anything we saw before, update our max value, or if it's smaller than anything we've seen before, update our minimum value. And then once the while loop's done, we turn the indicator light off to say, hey, we're no longer calibrating. Probably will tell that anyway because it'll start making terrible sounds. Anyway, I hope you enjoyed this video and found it useful.